combined gas law combines all the four gas laws above by setting their moles equal to each other from Avogadro's law. So if I look at my combined gas law, it's P1V1 over T1. If you cover the temperature, you have Boyle's law, P1V1 is equal to P2V2. If I cover the pressure, we have V1 over T1, V2 over T2, which is Charles' law. If I cover the volume, we have P1 over T1 equals to P2 over T2, which is, so let's get this first problem. We're going to identify the variable. If it's at STP is standard temperature and pressure, we're going to identify these variables later because we want to know what the current units are so we have less work in conversions. So if I look at a sample of gas, it occupies a volume of 24.5 mLs. We know this is volume because it's in milliliter. It wants you to calculate this gas at the pressure. So we're calculating a second volume. So that means 24.5 milliliter is volume 1. The pressure for the second volume is 2.3 atms. And the temperature for the second volume is 301 kelvins. So what we want to do is use the appropriate units for STP. Pressure 1, the standard pressure, since this is an ATM, the standard pressure we want to use is 1 atm. So if the pressure was in millimeters of mercury, we want to use 760 millimeters of mercury. If the pressure is in kilopascals, we want to use 101.3 kilopascals. Same thing goes for torrs and pascals. Temperature is in kelvins, so we're just going to convert this to kelvins, which is 273 K. So the only formula with two V's, two P's, two T's is the combined gas law. So this is going to be P1 V1 over T1 equals to P2 V2 over T2. If you're struggling with math, identify the variables and then solve for the variable that you are looking for. So we're going to cross multiply. So this becomes P2 V2 T1 equals P1 V1 T2. We want V2, so we're going to divide both sides by P2 T1, P2 T1. So the P2's cancel out and the T1's cancel out. So V2 becomes P1 V1 T2 over P2 T1. Now I'm going to plug in. So my initial pressure is 1 atm. My initial volume is 24.5 mLs. My second temperature is 301 kelvins. I do not have to convert it because it's already in kelvins. Divided by P2, which is 2.3 atms. Divided by the initial temperature, which is 273 kelvins. So if you look here, all the units do cancel out. We have atms on top and atm on the bottom. We have a Kelvin on top. We have a Kelvin on bottom. If you multiply all the tops and you multiply all the bottoms and divide it, you should get around 11.7 milliliters, the leftover units. So if we count the number of sig figs, there's 3 sig figs here. These don't count because these are constants. There is 2 here, and there's 3 here, so my final answer should have 2. So it should be 1, 2. I look 1 to right, so this is 12 milliliters. Pause the video, try this problem on your own, and then check your answer. So a gas has a volume of 5.23 centimeters cubed. So we know that the volume is equal to 5.23 centimeters cubed at a pressure of 72.6 kilopascal. Again, if you cannot recognize the numbers, what variables go with it, recognize the units, and that will help. It also has a temperature of 25 degrees Celsius. What is the volume? So we have a second volume. So that means this one was volume 1. If the pressure was changed to 124 pascals, so that's pressure 2, 124 kilopascals. And the temperature is 0 degrees Celsius. So this is pressure 1 and temperature 1. So the only formula with 2 V's, 2 P's, 2 T's is the combined gas law, which is P1 V1 over T1 equals P2 V2 over T2. So we can isolate and solve for V2. It is the same step as above. So V2 becomes P1 V1 over T2 over P2 T1. You don't need to isolate the variable. You could leave it in the other format if you're not having trouble with math. So now I'm going to plug in. My P1 is 72.6 kilopascals. My V1 is 5.23 centimeters cubed. My T2 is 0 degrees Celsius. I need to add 273 to convert to Kelvin. Divided by P2, which is 124 kilopascals, times temperature 1, which is 25 degrees Celsius. We need to add 273 to convert it into kelvins. Do the work in the parentheses first, multiply the top. Do the work in the parentheses first, multiply the bottom, and then divide to get approximately 2.8. So now let's go back and do sig figs. This one has 3 sig figs. This one has 3 sig figs. 25. So if I do 273 plus 25, I'm going to line it up here. So this one's going to have 3 sig figs. This one, 124, has 3 sig figs. Temperature 273 plus 0. This 0 has to be significant because that's the only digit given. So this one will also have 3. So my final answer should have 3 sig figs. So this is going to be 2.80 units of centimeters cubed. Because the kilopascals cancel out, the kelvins here cancel out with the kelvins here, so you have centimeters cubed left over. The ideal gas law, which is PV equals nRT, pressure times volume equals to moles times R, which is the gas constant, and temperature, is for hypothetical gases. Real gases do not behave ideally. Later on, we'll discuss the difference between ideal and real gases. P stands for pressure. In this formula, the pressure unit must be in ATM. Volume V must be in liters. N, which stands for moles, must be in moles. Temperature is always in kelvins. Because the units of the gas constants are ATM, liters, moles per Kelvin. You need to memorize the gas constant R, which is 0.08206 ATM liters moles per Kelvin. In the previous problems, we didn't care what the units were. As long as the pressure units were the same units when we plugged it in and solved, the volume units were the same when we plugged it in and solved, and temperature was always in Kelvin. Because the gas constant, you must always be in ATM, liter, moles, and kelvins. If not, you need to convert the units. Calculate the pressure in kPa's of 0.421 moles of helium gas at 254 Kelvin when it occupies a volume of 3.32 liters. So we're going to identify, we're solving for pressure, P. We have the number of moles, N is given as 0.421 moles. Kelvins, 254 is the temperature. And the volume is 3.32 liters. The only formula with 1P, 1N, 1T, and 1V is ideal gas law. PV equals nRT. So I'm going to plug in. I'm going to solve for P. The volume does not have to be converted because it's already in liters. This is equal to the number of moles, 0.421 moles, times the gas constant, which is 0.08206 atm liter moles per Kelvin, divided by my temperature, which does not need to be converted because it's already in kelvins. So we can solve for the P. So we're going to multiply all the numbers on the right side and divide by 3.321 liters. So P is equal to 2.643. This is in units of atm, because if I simplify the units, there's a liter on this side, a liter on top, that cancels out. A mole on top, a mole on bottom cancels out. A Kelvin's on bottom, Kelvin on top. So the units that we are left with is atm. The answer we want is in kilopascals, so we need to convert. So we're going to start with 2.643 atm. Diagonal units have to be the same, so atm. And we're going to go to kilopascals. So that's 101.3 kilopascal is 1 atm. You need to memorize the conversion factors. This equals to 267.74. I usually don't do the sig figs until the end, as long as you keep track of them. But if you want to do sig figs here and then plug that number here, it won't make much difference in your answer. Now, everything is multiplication and divide, so I need to count. So the moles, there are 3 sig figs. Temperature, there's 3. Volume, there is 3. My conversion factor doesn't count, so I need 3 in my answer. 1, 2, 3. I look 1 to the right. Is 268 kilopascals. So we have a 500 gram block of CO2, so that means there's a mass of 500 grams. Vaporizes a gas at room temperature. Calculate the volume, so we're looking for volume. Produced at 25 degrees Celsius, that is the temperature for the room. And pressure of 1.50 atm. Only formula with 1P, 1T, 1V is ideal gas law, so this is PV equals nRT. So now I'm going to plug in. The pressure is 1.50 atm. The volume is what we're looking for. We don't know the moles, but we know mass, so we could use molar mass to convert to moles. So 500 grams of CO2. Gram CO2, 44.01 grams of CO2 to 1 mole CO2. Gas constant is 0.08206 atm liter moles per Kelvin times the temperature, which is 25.0 degrees Celsius, needs to be converted. So you need to add 273. So if you are struggling with math, do all these math separately and then plug it into the equation. So you're going to multiply all the right side after you do the work inside the parentheses first, and then divide by 1.50. So V equals to 185.214. So now I'm going to go back and do sig figs. There are 4 sig figs here, decimal significant digits, so all those zeros are significant. For the temperature is 25 plus 273, last significant digit, so there's going to be 4 sig figs here. My pressure has 3 because decimal significant digit, that's 0 significant, so we have 3 in the answer. 1, 2, 3, I look 1 to the right. This becomes 185 liters. So for the gas laws, to make it easier, identify the variables. If you are struggling, identify using the units. Once you identify the variables, the equation will come. If you are having difficulty solving, Then rearrange the equation for the unknown variable and then plug in. You could also do all the conversion outside the equation and then plug it in. And make sure you do sig figs and unit.